Welcome to episode 1 of our tutorial series, and where we will demonstrate how to develop your apps with Overledger integrations. In this episode, we will be showcasing how easy it is to deploy smart contracts and interact with them using the Make integration.
Today we're going to demonstrate how to use Make.com and the Overledger module to deploy a token across multiple blockchains to the same contract address. The assumption we're starting with is that you have a signing account which has the same nonce across the blockchains you want to deploy onto. The nonce is what dictates the resulting contract address. So let's start off with the webhook, which gives us an endpoint to send some data to. We're going to send some data defining our deployment details using Postman. We have a repeater module here. So as part of the data we're going to send a list of networks. So this will loop for every network we define. So we'll repeat the remaining steps multiple times if we define multiple networks. We have a router in place here. If as part of the data we're sending, we're defining a true or false to define if we're deploying to that blockchain or not. If we are deploying to the blockchain, we follow the top step. If we do not want to deploy, we follow the bottom step. The top step will deploy the token. The bottom step will perform a zero value transfer to yourself. That will allow the signing account to synchronize nonces across the blockchains. Rather than if we just deployed on one blockchain, it would mean the other blockchain in the request has a lower nonce, so any future transactions would not keep the contract addresses in sync. So let's have a quick look at the top step. First, we prepare a basic token deployment. So we need to pass in the network, which we get from our webhook. We define the token name, symbol, decimals, supply, and initial token receiver, all from the webhook data. I will show you that in Postman in a minute. We take the resulting native data and convert it to JSON using the JSON module. We take the JSON and we pass it into the native data. We define that we want it signed using the CTA signer. We take the request ID from the prepare step and our signing key ID. We then get a signed transaction response, then we pass that to the execute a signed smart contract deployment transaction step. And we pass in the signed data and request ID. If we are not actually deploying, then we will just prepare a native asset transfer. And there we just need to pass in the network, the unit. We're going to say it's a zero amount, and then we're just sending an amount from and to the same address. We convert that prep native data to JSON, and we pass it to a signed transaction, same as above. And the last step is just an execute, where we pass in the signed data. So let's run this. Let's test this by using the run once option. And we'll wait for new data. I'll go into Postman, and here we define all the token information that we talked about earlier. We define the networks, so we're deploying onto two networks. We're saying true to both, and we're defining the native asset type. And we'll press send, and we'll go back to our flow here, and you'll see everything goes green, indicating that it was executed successfully, and you have a 2 indicating it was executed twice, once for each blockchain. If we click here, we can get the transaction hashes of each of our deployments to confirm that it was deployed and check the contract address. So you'll see the contract is still pending. So let's check out the AVAX. The AVAX was deployed to contract 0B04, and Sepolia was also 0BB4, and it's 0BB4. So the same contract address on both blockchains. And let's refresh that, and we'll see that we also got the token transfer. Today we're going to use Make and Overledger to deploy a contract on multiple blockchains and keep the same contract address on every blockchain. The assumption here is you're starting with a signing account which has a 0 nonce on every blockchain, or at least the same nonce on every blockchain. The nonce is what dictates what address you end up with on your contract. So let's start off with a webhook, which gives us an endpoint to send data to. We'll send our request information to that in a moment using Postman. I'll describe that later. As part of the information we're sending, we're defining what networks we want to send to. So what we use the repeater function for is we loop through every network you define in the request and deploy onto that network. We have a router module in place which does one of two things. If you enable deployment on that blockchain, it will take the upper path and actually deploy the contract. If you disable deployment on that network, it will take the lower path, and what this flow does is just send a 0 value transaction to yourself. And what that does is it keeps the account and nonce in sync across multiple blockchains. So if you decided to deploy to one network and not the other, and we only did the top path, it would mean the address on that network nonce will be 1 higher than the other network. So let's quickly go through what we do. So we prepare a smart contract deployment transaction. For that, we need the contract bytecode, which is sent to the webhook. We'll show that using Postman. And we take the deployment information out of the request as well. We transform the native data back to JSON using the JSON module, and we pass that into the signed transaction module. For that, we take the request ID, which is a response from the prepare step. We say we want to sign it using the CTA signer, and then we pass in the JSON string created by the JSON module. And that will respond with a signed transaction, and then we can pass that to the execute assigned smart contract deployment transaction, which takes the signed object and the request ID. The lower path, which is just a 0 value transfer to yourself, is simply picking the instance and the tech. You take the network from the input data. You then can specify the transfer amount. So for our case, we're just saying we're transferring 0, and we're taking the unit, which is ETH or AVAX or XRP or whatever the network is, and we're transferring ourselves a 0 amount. Again, we transfer that native data to JSON, and we pass it to the signing transaction, same as the step above. And because we used a V2 endpoint step here, we need to use the V2 sign transaction stage. So let's have a look at Postman to see what the actual data is. So here's our webhook URL that we showed you at the start. We're defining that we send in the deployment information, which is a list of networks, a list of booleans indicating which of that list we want to deploy onto, and the native assets associated with that list, and then the actual bytecode of the contract we want to deploy. So let's test that out by clicking run once, wait for new data. That'll just allow us to test and see the execution flow and the resulting data. So let's go back to Postman and press send. Then we can pop back to Chrome, and you will see the green progress across the screen. So here we had a true statement for both of our networks defined. So we executed the top path twice. You'll have a 2 on each of these telling you how many times you executed it. And let's have a look at the results. And we'll get a transaction ID out of each one. The first one was for Sepolia, so let's have a look on Sepolia. And we resulted in a contract deployment starting with 0xAE6, and the other contract on Fuji testnet was the same. Thank you very much.